and systems of inequalities. All right, right there is an example of a system of linear inequalities.
Are they solved the same way as equations?
You graph them the same way, yes. But remember, when we graph inequalities, what did I tell you was the most important
Solid or dotted?
part? The shaded region. Okay? So the most important part of our graph here is the shaded region that satisfies both inequalities. All right? Because every point within your shaded area is a solution to the system. Every point outside of the shaded region is not a solution. Okay, so write that first one down. What form is this one in?
That is in
standard.
Standard.
form.
Here?
That is
Slope
in
intercept.
Slope intercept. I would leave this one in standard when I graph because I can easily find the what?
The X
Slope.
and Y and
X and Y intercepts.
Slow down,
And here I would leave this in slope intercept form. Okay? Looking at the first one, what is the x-intercept? 6. What is the y-intercept? -3. What's wrong? Her.
I just
Okay? Remember,
How's the x-intercept 6?
to get the x-intercept, you set y equal to 0, or you basically ignore this, and you're left with x equals 6.
Oh,
To get the y-intercept, you set x equal to 0, or basically ignore that and solve for y. Y would be -3. Okay, plot those 2 points, and do you have a solid or dotted line?
dotted.
Solid or dotted?
Dotted.
Look at the camera.
It is a dotted line.
Whoa.
So there is what we have. Dotted line. Here are my intercepts, 6 and -3. And we know, now when you shade each of them separately, I wouldn't shade them to start with. So when I graph this first one, I know to shade above it. The reason I know that is I can pick a point. What point's easiest to pick?
0,
0, 0. When you plug 0 in for x and 0 in for y, what am I left with?
0 is less than 6.
0 is less than 6. Is that true or false? That's true. So that tells you that 0, 0 is part of your shaded region. We know to shade above this line. Okay? Now the next line. Slope intercept form. What's your y-intercept?
5.
5. Slope.
-3/2.
Down 3, right 2. We know it's a solid line. If we want to plug in a point, 0, 0 will work again. Is 0 less than or equal to 5?
Yes.
Yes. So that tells me to shade towards 0, 0. So for the blue line, I'm shading above. For the red line, I'm shading in this direction.
So we can choose
Which area satisfies both of them? Right here. So there is your answer.
Just keep going.
What's your question?
So you can choose any point to plug in?
Yes, as long as it's not on the line. Again, 0, 0 is the easiest point to pick, as long as it's not on the line. If it is on the line, you gotta pick another point. Yeah.
So anytime we do inequalities, we always shade.
Yes.
Okay.
Okay.
So you don't really have to solve anything for this. You just kind
Well,
of.
your solution is the shaded region. Every point you pick in here will give me a true system. Every point I pick in these 3 regions might work in one of them, but not the other.
How do you
How'd
write
you get the
that?
blue line?
You don't, you just graph it.
The blue line, the intercepts.
Yeah.
X-intercept is 6, Y-intercept is -3.
How do you write the answers?
That is the
That is the
answer. You
answer.
don't
I
write
do,
it.
Okay? All right, next. Y is less than 4. Whenever you have y equals a number, what type of line is it?
It is a
Horizontal.
horizontal.
So we have a horizontal line going through 4. We know it's dotted because there's no equal to sign. And less than means you shade below it. So for this one, we're going to shade below this line. Absolute value graphs, we just finished that. You know it should be a V shape. You should be able to look at it and tell whether it opens up or down. How do you know it opens up?
If
It's greater
it's
than.
positive.
Positive.
Because it's positive in front of the absolute value. And you should be able to look at it and tell me the vertex is
3, 0.
3, 0.
Zero.
Okay? So you put a point at 3, 0 and just open it up. If you want to get exact with it, you can do a table of values.
No, thank you.
We know it's a solid line. And for greater than, you would shade inside of it. And the region that satisfies both is right in here. So your solution is the set of points inside that triangle area.
Please,
Okay? Question?
please do.